as well.
The blessing and curse of an invention often lies side by side. On the one hand, it is fascinating that seawater might one day provide the solution to one of humankind's biggest existential problems, that of energy. On the other hand, we must realize that mass combustion of salt water might also have dramatic effects on the ecological balance of our planet.
Research continues, of course, even when no immediate benefit is expected. At the University of Technology in Graz, Austria, young scientists are seeking to discover why water placed in two glasses and subjected to a high voltage charge will climb the sides of the glasses to meet. It doesn't do it at some random part of the glasses, but at exactly the spot where the water from the two glasses will meet. If one moves the glasses away from each other, the water creates a hanging bridge that can be up to 2 centimeters long. So far, even the world's greatest scientists have been unable to explain the phenomenon. So far, there is not even a theory about the sensational behavior of the water.
An exact microscopic theory and an exact understanding of what is happening here, we haven't found that yet. And that is the reason that we're continuing to work on it. It's what makes this all so interesting. We would expect electrolysis, but under no circumstances would we expect a stable bridge that acts the way we see it acting here. That's what makes this all so fascinating. A half hour later, the bridge fatigues and collapses. Through the use of a red and a blue color filter, the movement of the bridge becomes more visible. It is the apparent flickering that amazes the scientists. From a physical point of view, it should not be taking place in this form because water cannot be compressed. Here we're using the same kind of measuring technique that we use in mechanical engineering, anytime that we're dealing with very high speeds in a machine, whether it's rotational speed or flow velocity. It requires a special measurement technology, which we're using here on the water bridge.
One can see that blue is trying to get to the red side and red to the blue side. The next step in examining the phenomenon more closely is the use of a thermal imaging camera. With its help, we can see more clearly the mysterious processes taking place within the bridge. It is not difficult to see that all hell's let loose here.
The problem with such measurements is always that every measurement poses new questions instead of providing new answers. That means that we are constantly observing dynamic effects, and they raise questions that we cannot answer. So we have to consider new measurement processes that would allow us to find out, for example, where the structures that we observe in this water bridge come from.
For the layman, it looks as though water could breathe. But for the scientist, it continues to be an unexplained phenomenon for now.
Since we're using pure water and have verified that that's the case, we can't be seeing foreign bodies here. There can't be gas bubbles either. It's water in any case, but it is different water. Water that has a different structure at a different density.
Despite all the problems that water poses to science, one thing is certain: its beauty is a great pleasure to behold. Scientists in Israel are also experimenting with water's ability to retain information. Here the measuring instruments are bacteria.
If you expose water to weak electromagnetic radiation, the effect should be erased within milliseconds. Not only that, but even if there is some effect, it should be so weak that even our best and most advanced tools, of technological tools, will not be able to detect the differences. But the bacteria can do it. Not only they can detect the differences, but what they can do, they can amplify it to the point that we can look at the colony, that it's going after the bacteria were exposed to water that had some weak electromagnetic radiation, that they can go 2 or 3 times faster than the other bacteria.
Researchers at the School of Physics and Astronomy at Tel Aviv University are exploring the question of whether water can tell when it is subjected to weak electromagnetic radiation.
Use the bacteria as our detector to tell us or to show that really some changes have been occurring in the water, and these changes actually, we expose the bacteria after some time, an hour, 2 hours we can, that these changes that were induced could survive for a long time.
The experiments have led to interesting results.
We have preliminary results, they are not published yet, and it seems, it's preliminary results, it seems that there are many genes that are related to metabolism, related to development of the bacteria that are upregulated. So they really sense something in the water.
The internal structure of water molecules remains a mystery. Science attempts to penetrate the interior of the molecules, to study them, and to get a systematic picture of them. But even the most modern computers have their limits.
We really don't know exactly everything what happened there, but I can tell you for sure that if a molecule entered to water, so a lot of things changed. First of all, the molecule. The second, around the molecule you have a shell that we call it solvation shell of water molecule that surround this molecule and making the molecule different from the molecule outside water. So molecules can behave differently in water. And it's very interesting. Now, this molecule that you enter to the water will change all the molecule around that was before in the water. So it's a lot of complicated things. If water will be in a magnetic field, so they will behave differently. Sometimes totally differently, because in magnetic field, all the paramagnetic species, it means the species that can change their behavior according to magnetic field that are in the water will behave differently, and they will change the chemistry in water. So it's very interesting to understand that water can change according to their area, to the area that surround them.
We got like 13 different types of water, and each one of them was analyzed with the LCMS technique, and we could see great picture because the different types of water gave us a really different picture of the inside of the water, the compounds that were inside. Many organic compounds mainly, but it's the first time we got a picture where we could see with our eyes that different sources are giving us different types of water, different ion matrices inside the water.
There is much to be discovered about water in the great outdoors as well. But to do that, one has to have the gift of seeing rivers and streams as partners. An Austrian river engineer has found a unique way of doing this.
Wenn man in den Fluss oder Bach oder Bächlein hineinhört,
When you listen closely to a river or brook or stream, you immediately recognize its character. It's quite simple. If the stream is loud, I know I'm dealing with an energetic stream. If it's quiet, I'm dealing with a more gentle body of water. And thus, there is a very important distinction that I can make.